Hello everyone, I am Ayush Agarwal from ABES Engineering College, and in our today's lecture of DBMS will be covered by joins and group by clause. In our previous lecture, we have discussed the concept of subqueries and we have understand that how these subqueries will work and in which clauses the subqueries can be embedded, right? Now, in today's discussion, we'll discuss the different type of joins. We'll discuss what is the purpose of join, and we'll discuss different type of join with the help of an example. And after that, we'll discuss the concept of group by clause. We'll discuss that how this will work and what is the concept of having in group by clause. Okay, so let us start with our discussion for today. So now what is join? So basically in relational database, we have already covered the concept of join. So what is join? Basically, it is used to combine different tables, right? So in tables and relationship, in terms of relation tables and relationship, data is divided into tables for better understanding and better organization to reduce redundancy. We have when we will use the normalization concept, so in that case we'll divide the concept of tables into further tables, into subtables, right? And this is because due to reduce the redundancy and to increase the consistency of the data. Now, these tables are connected by the relationship, often using primary and foreign keys. We have understood the concept of primary and foreign keys, and when we have discussed the concept of foreign keys, we'll understand that these foreign key will be used to combine these multiple tables. Now, what is the purpose of join? Basically, this allows you to fetch data from different multiple tables in a meaningful manner, right? For example, combining customer details with their order information. So we have one table, we have one table for customer, we have one table for order. And if we want to identify or if we want to fetch the information that which customer has order which particular product, so we'll need to join those tables. And after that, we'll get information from these joins after joining the tables. So basically, if we discuss the concept of join, how to fetch the data. So basically, how to fetch the data using multiple tables. This will be the example here. We have shown that to show which computer is allocated to which employee. So we have here employee table, we have here computer table. Now we'll need to identify which computer is allocated to which employee. So when we have discussed in relational database and in relational algebra, we understand that while using the joins, we need at least one common particular attribute in both the tables. So here we have comp ID, and this comp ID is common in both the table. In employee ID, this ID will be treated as primary key, and in this computer table, this computer ID will be treated as primary key. Now this computer ID will be added into the employee table as your foreign key, right? So this will be used to combine the particular table. Now, while we joining these table, we need to identify the values of these particular foreign key, right? So we if we are using inner join or if we using natural join, so we need to check the match tuples here. So if we talk about this 1001 value, so this will have this particular match tuple 1001 here. So it means this particular row will be considered in the relation in the resultant relation. Now whether this 1001 will have another match tuples, no, this will be 1002, right? And if we talk about this particular null value, so it will not have any particular match tuple. So in this resultant table, only one result will get for this particular employee in computer table, and to show which computer is allocated to which employee. So here we will get the result. It means that this James Potter will allocated this computer ID 1001, and this model is Vostro, right? So this particular match row will be matched with this particular row. In this manner, we will combine the data. Now we have different type of joins, as we have already discussed when we have discussed the concept of relational algebra. So we have inner join and we have self join. These are the concept under inner join, and inner join we have already discussed the concept of theta join and natural join and equi join. When we talk about outer join, so we have three kind of outer join. We have left outer join, we have right outer join, and we have full outer join. So let us discuss one by one with the help of an example all of these type of joins. Now, first of all, we understand what is cross join, and we have also understood in the relational algebra that uh, this cross join will be used or will be used to merge these two tables or to a particular or two or more particular tables, right? And it is also known as the Cartesian product, right? Now, cross join with m rows in table 1 and n rows in table 2 will result in m into n number of rows. We have already understood that. Now, this is a table of employee and this is a table of this is the table of computer. When we will combine these two particular table from cross join, so we'll get m into n number of rows. So, for example, here we have 5 number of rows and here we have 4 number of rows. So total number of rows we will get here is 20. What will be the syntax that can be used to perform the cross join? So here we have select employee ID. Here we have select employee name, comp ID as ecomp ID, then again c comp ID, because this comp ID is present in both the table, and this will be treated as the primary key for this, and this comp ID will be treated as the foreign key, right? And this particular attribute is mainly used to combine these two tables, right? And then we have display the model from the computer table from employee cross join and then computer. So here we have used this cross join operator. What does it perform, or what does it do? It will create, or it will match, or it will perform the first table, first row of the first table with all the rows of another table. So it will match all the tables, right? Now the second row of first table will match or will perform the matching of from the second table of all the rows. So in this manner we'll get the total number of rows as 20, because in this table, first table, we have total 5 rows, and in second table we have 4 number of rows. And as we know that in particular cross join or Cartesian product, we'll get m into n number of rows, right? Now we'll talk about inner join. So basically inner join is most commonly type of join which combine the data based upon the common predicate. Common predicate, it means that we need at least one attribute here in both the tables, that in both the tables. Basically we have to create a foreign key concept basically to relate to different tables. So in this case we have comp ID. Here is the primary key for this computer table, and this comp ID will be added into the employee table as the foreign key. Now we have this common attribute among these two tables, so we can perform this particular inner join. So now what will be the syntax we will use to merge these two tables? So here what we need to display, we need to display ID, ename and ecomp ID as ecid from employee table, and ccomp ID as ccid, and model from the from the computer table, right? Now in the from clause, what we need to do, we need to perform inner join, right? So what we have done here, employee as e, and we need to write inner join, and after that we use computer table as c. Now this is the condition for inner join. At least one at least one attribute must be same in both the tables. So this will be considered using on clause, right? So here what we have done here we have performed inner join between these two tables, computer and employee, with the condition that the e.comp id, it means the comp id which will be present in employee table, and the comp id which will be present in computer table must be same, right? So this will be the concept of inner join. Now next we have, so if you can see that here we have here we will get these two number of rows when we perform the inner join on these two tables. Now we have self join, right? Self join, basically it is a join in which a table is joined with itself so as to retrieve a set of information. So basically what we'll need to do in case of self join, here we have only one table and we need to join these single table multiple times, or you can say twice, right? So here we have employee table as alias add as emp, and here we have employee table as alias add mgr. Now what will be the question? The question is to know the employees who are reporting to some manager, right? So we need to identify those employees who are reporting to some at least manager. So if we talk about this employee table, here the name of the employee is given, the id is given, salary is given, right, department is given, and here the manager is given, and in this case this is the id of the manager. So if we talk about this first particular row, here first is James Potter, and will it report to some manager? Yes. To whom? Whose ID is 3. It means James Potter is reported to Emily Rayner, right? If we talk about this second ID, whose name is Ethan McCarthy, and will it report to some manager? No, it will not report to any manager. So if we talk about this third, so is Emily Rayner will report to some manager? Yes, it will report to the manager whose ID is 2. It means Emily Rayner is reported to this Ethan McCarthy. So in this manner, we can perform the self join here. And what will be the concept? What will be the syntax for using a particular self join? So here we need to identify the employee ID, and this employee ID is from emp, and here we have used alias as emp, right? Now again, next we have employee name as emp name. Now we have manager id, right? So here we have used manager id because we need to combine these two tables, and both the table will be the same in case of self join. And after that we have used here manager name as mgr name from employee, and you can see here from employee emp, and we have performed inner join on again employee as mgr. So here we have used the same table before applying the inner join, and you already know that if we perform inner join, so there will be a condition which can be applied from on operator or on keyword. Here we have emp dot manager. It means this particular if we talk about this particular attribute, so emp.manager equals to mgr.id. It means this particular id. If you see that this is the id, it is the particular primary key for this employee table as mgr, and this can be used to add in the employee table named as emp as manager, and this will be treated as your foreign key, right? So in this manner we will identify the employee who are reporting to the sum manager. So if you see that the result, so here if we talk about employee id 1, James Potter, as we have already discussed that here is manager id is 3 and manager name is Emily Rayner. If we talk about Ethan McCarthy, so his manager is null. It means that it will not report to any particular manager. If we talk about Emily Rayner, so here we have Emily Rayner in the second. He is reporting to the manager whose ID is 2, and whose ID is 2, that will be Ethan McCarthy. So in this case, we'll get only 2 rows, right? So this is the concept of self join. Now we have now we have outer join, as we have already discussed in the relational algebra, that outer join is used to or is dealing with the missing values, right? So basically when we will perform outer join, so first of all we'll need to identify what kind of outer join we'll use. We have right outer join, we have left outer join, we have full outer join, and and after that we first of all we perform inner join. It means the all the matched tuples will be returned in the resultant relation. And if we talk about the kind of outer join, so if we'll use right outer join, so all the unmatched tuples from the right outer join will also be considered in the resultant relation, right? Now if we talk about right outer join, so basically it is a join in which all the rows of the table B will be returned, and matching rows of table A will be returned when we join these two tables. So basically we have employee table, we have computer table, here we have primary key as computer ID, here we have comp ID as foreign key, and here we have ID as the primary key of employee table, right? Now to fetch the details of the computers who are either allocated or allotted or not allotted to any employee, it means we need to fetch all the values of computer table. So it means we have performed right outer join here. So what will be the case here? All the values or all the rows will be in the resultant relation. You can see here 1001, we have 1001 here as a comp id, and 1002, for 1002 we have also the 1002 as the in the resultant, because we have known that in right outer join all the rows of the table B will be returned, right? So first of all, as we know that first of all we will perform the inner join. So this 1001 is a match tuple with this 1001, so it will be definitely be the return in the resultant relation. Now if you see that in the employee table, so no other particular value of comp id will be match tuples from the computer table. But in case of right outer join, if we talk about this particular value 1002, it does not have match tuple in the employee table, but in right outer join this will be also be used in the resultant relation. So in this case we does not have a match tuple, so here in id and employee name and employee cid will be null, right? And in case of cid and model, we have this particular 1002 and model will be precision. Now what will be the syntax we'll using here? So what will be the attribute we want to display here? We have to mention here, here we have id ename comp id as ecid, c dot c comp id equal as ccid and model, right? Now from employee right outer join, now here we have used right outer join compiled computer C, and again while performing right outer join we need to perform this particular operation with the help of this on keyword, right? So it means that we need to perform inner join first, and after that we add all the unmatched tuples of the table based on which kind of outer join we are using. So if we are using left outer join here, so what will be the case? In this case all the rows of employee table will be returned. In this case if we are using left outer join, so here we in the resultant relation we will get 3 number of rows, because this particular value have a match tuples, but these two values will does not have a match tuple, but these will also be included in the resultant relation of left outer join. Now, what is the full outer join? So basically, if we combine a right outer join and left outer join, so basically this will be the concept of full outer join. It means that if we have computer table and we have employee table here, so basically first of all we will perform the inner join here. So we can see that here only one match tuple between these two tables, right? And after that we will merge both the rows of the table. So you can see that in which all the rows of the table B will be returned and all the rows of the table A will be returned when we join these two tables, right? And full outer join between A and B return matched as well as unmatched rows from both the table. So in this case we'll get this one match tuple. You can see here in this case we'll get one match tuples, but these two values or these two tuples does not have any match tuple, but in the resultant relation we have included also these two values. You can see that this will and this one, these two values will be from left outer join, and this particular last value will be from right outer join, because this 1002 will also be does not have a match tuples. So basically in full outer join we'll first of all perform inner join, and after that we'll consider all the unmatched tuples from the table A and from the table B, right? What will be the syntax now here? Same, but in case of right outer join here we have used full outer join, and this with the condition will be the same, that at least one attribute in both the table must be same. In comp id here we have same, in this case this will be the considered as foreign key, right? So this will be the concept of full outer join. Now, I will move to the next topic, that will be group by clause, and this is very important again topic while we considered the SQL command. So basically, the group by clause is in SQL command that is used to group rows that have the same values, right? And it is used in the select statement. We'll discuss one by one. And optionally, it is used in conjunction with aggregate function to produce the summary reports from the database. Let us first understand the syntax of this group by clause. So in this case, first of all, what we'll need to do here, select, after that we need to mention the group, the column list we need to return, and the group function or aggregate function which we need to perform, right? As you can see that here, group by clause is used in conjunction with aggregate function. So while we're using group by clause, so we can take a column, and this column must be the same onto which you are performing group by clause, right? We'll understand with the help of an example. After that, we use aggregate function. Now this from the table, we can use this where condition, and after that we have used group by clause, right? And this group by clause will have group by expression, and expression can contain column name also, right? And after that we can use order by column, right? Now if we take an example here, what we have here, we have department ID and we have salary. So now what we need to do, we need to find the average salary in employees table for each department. Now we what we need to understand here, we need average salary for each department. It means if we talk about this department ID 10, so we need to identify that this department ID 10 will have average value. If we talk about this 20, so there will be two employees whose department ID is 20, and we need to find the average salary of both the employees. If we talk about this particular value, so it will have multiple employees under this department ID, and we need to find the average salary of this employees. So in this case, we need to group the particular column, right? And based on which we need to identify the average salary, we need to perform the grouping. So in this case, what will be the syntax here? Let's suppose we have used, if we talk about this particular output, so what we need to do, we need to perform select, and what we need to do, we need to identify department ID and average of salary, right? And from which table? From, let's suppose, employee table. And whether there will be any condition? No, there will be no any condition, right? So directly we will be use group by clause, and based on which attribute we have used group by clause, that will be department ID. So we have used department ID as the in the group by clause. So this will be the syntax to find the average salary in employee table for each particular department. So if we see that here we have 10, and this will be the average salary of 10. Here we have average salary of the department ID 20, and so on, right? Now in group by clause, basically, first of all, we'll need to understand something or the features of a group by clause. So basically, all columns in the select list that are not in group by function must be in the group by clause. What does it mean? It means that what will be the if we are using this department ID in the group by clause, so it must be there in the group by clause. So it should be included in the select statement, right? But if we have anything, any column in the select clause, so we must include that particular attribute in the group by clause. So this will be the first feature of group by clause. Second, all column in the select list that are not in group function must be in the group by clause. So we have understood that here we have group based on department ID, and here we have only average salary. So what we need to identify, that based on which attribute we are performing group by clause, right? So only that particular attribute can be added in the select list in conjunction with the group function. But if I am writing, let's suppose, select, and let's suppose name, right, comma, average salary from from EMP and group by department ID. So will it works? No, it will not work. Why? Because we have here name attribute as in the select clause or select list, right? So if this particular attribute is included in the select list, so this must be added in the group by clause, right? And you can say that if any particular attribute is included in the group by clause, so only this particular attribute can be added in the select clause other than aggregate function. So these are the properties of group by clause, right? Now we can here in previous case we have seen that we are grouping here with the help of only one column. Now we can also grouping by more than one column, right? For example, add the salary in the employees table for each job grouped by department. So now in this case we need to perform grouping based on two columns, based on multiple columns. So what we need to identify here, first of all, we have used department ID, we have used job ID, and we have used some of salary from employee and group. What we have done here, group by department ID and job ID. So now first of all check whether this syntax will be correct or not. So we have already understood that whatever the attributes is included in the group by clause can be added in the select clause only, right? So here we have used department ID, here we have used department ID, here we have used job ID, here we have used job ID. So this particular syntax is correct. Now what we have done here, first of all we'll perform group by clause based on this department ID, and under that department ID, if the job ID is different, now that will be again grouped, and based on that we need to identify the sum of salary, right? So in this case what we need to identify, that you can see that this 90 will have three particular job IDs, right? So 90 with this particular job ID will be different, and for this 90 this job ID will be different. So we need to group these two differently, right? So first of all we have 90 with this particular job ID, and the sum of salary is 24,000. So you can see that if we are using here let's take about the example. So if we talk about this 90, you have two particular values. Now you need to sum of these two values, because this 90 have three values. So can we group into one? No, because we are using grouping by more than one column. So here job ID is different for this 90, and there we have job ID is different for these two different values. So for this particular 90 value we'll use two different groups. In this manner we can use group by clause by more than one column, right? Now, what will be the illegal queries using group by clause? We need to understand. So, any column or expression in the select list that is not an aggregate function must be in the group by clause. As we have already understood that here select department ID and count last name from employee. So can it work? No, it will not work, because any column or expression in the select list that is not an aggregate function must be in the group by clause. So whether we have used group by clause here, no. So this count function will not work, right? Now next we have, you cannot use where clause to restrict groups, right? You need to have the having clause to restrict groups. Now what will be the case here? Let us take an example. For example, here we have identify average salary in employee table for each department. Now we need to identify the average salary in employees for each table for each department where average salary is greater than 10,000, right? So here what we need to do, we need to perform some condition. We need to perform some condition based on the grouping. So here we cannot use the where clause. Here we need having clause that can be used to restrict the groups, right? So basically if we talk about this, so here we have used department ID and average salary from employee till now we have a correct syntax. Now where average salary is greater than 8,000, will it correct? No. In where clause we cannot use the aggregate function. Here we have used group by department ID, and if we need to restrict this particular attribute or this particular group, so we need having clause in instead of where clause. And having clause can be used or will be used after the group by clause, right? So this will be the illegal query using grouping function. Now, how we can restrict group results using the having clause, and we have seen that while using the having clause, groups rows are grouped, the group function is applied, and after that group matching the having clause are displayed. So in this case, let us take an example here. The maximum salary per department when it is greater than 10,000. So what we need to identify, first we need to identify for each department what will be the maximum salary, right? So what we need to write here, select, let's suppose select department id and max of salary, right? From which table? From employee table, right? Whether there will be a condition, yes, there will be a condition, but that condition will be applied on groups. So we will not use here where clause. So group by, what we need group by will be based on department id, because we need to identify the maximum salary for each department, right? So we need to group based on group id. Now after that we will use having clause, and having clause will have that maximum salary must be greater than 10,000. So what it will do, it will return only those department whose maximum salary is greater than 10,000. It will not display those particular department whose salary is less than 10,000, right? So in this case, or in this manner, having clause will be used. So you can see that what will be the scenario, what we have written in our previous slide. Select department id and then maximum salary from employee, group by department, and after that we have using having clause, and what will be the condition, that maximum salary must be greater than 10,000. So this will be your output, right? So in this manner, joins and group by clause will be used in SQL, and these are the references through which we have taken the content to create this video. So if you like this video and you think it will help you, so kindly like and share. Thank you so much.